Hey YouTubers, it's RcMike back with you. Here in this video we're going to go over some techniques on soldering. Over the years I've had lots of people talk about soldering connectors and motors and being able to do it and not do it, and I've watched a lot of videos on people that I thought that were professional people in the hobby, and to be quite honest, there's always room for improvement. And generally I don't do these kind of videos on trying to show somebody up, and that's not what I'm trying to do. However, I do see a lot of techniques that are just completely wrong, and difficult, or not as easy as it should be or could be. We're just going to try to show you how I solder things, and I've screwed up more joints than I have good joints, so I've got some experience on soldering, good and bad, and I think all of us do. But over time you tend to try to get better and make things easier, and you get smarter as you make mistakes in life. So this video is not about trying to show anybody up because they made a video on how to solder. It's not about trying to show somebody up because I can solder better than them, or they are better at what they do. Sometimes it's about opinions on what should be done or shouldn't be done, and I see a lot of people that are clearly just not as experienced as maybe they think they are, or maybe they should be. And soldering on camera can be a little tricky too, because the camera's at a strange angle and you're soldering at a strange angle, and that can be some of the issues. But at the end of the day, the whole point is trying to teach somebody something and have it come out with a positive experience, and get better at something and not worse. So the intent is to try to improve someone's skills with this video. So hopefully that helps somebody, and that's the point of this video. So with that, we'll get started. So to start with, you need some sort of soldering station iron that's got about 60 watts or more of power, and not just any old thing. You want something that's fairly decent. A soldering station is going to cost, I would say $75 or more, and you can spend up to $200 on a soldering station. But for RC cars and for that sort of thing, around $100 is about a typical price. This one here is about $110. This is a Track Power 950. You can still get them. Duratrax, I think, sells them now. You just need a decent soldering iron that's got some power to it. Otherwise, you'll sit there and hold it and hold it and hold it, and it won't heat up your wire, but it'll burn up everything else. So you want something fairly decent. So that's the first thing that you need to do. If you try to solder with a 25-watt soldering gun and think you're going to get this big 10-12 gauge wire heated up, well, it may not work as good as you might think. So in any event, one of the basic terms that is often used when soldering is solder flow. And solder flow is kind of important, because if you don't do it right, then your connection is not going to be correct. So solder flow refers to the actual solder melting onto the surface that it is being applied to. And that's important because if you don't get it hot enough, it won't flow, meaning saturate or get hot enough to stick to the metal that it's actually being applied to. So solder flow is really a process that everyone skips as far as learning how to do this. And if you get this first step wrong, there's no way you're ever going to do a solder joint correct. We're going to demonstrate solder flow and what that looks like in several different applications. The first step is to get it to flow on your iron. So this iron is set at about 700 degrees, and all you got to do is touch the solder to the iron, and it will basically flow onto the iron. And right there, the solder is now melted and it's flowing onto that iron. So that's step one. The next step is understanding why it's important to get the piece of material hot enough to actually melt the solder rather than melting the solder on the iron. So we're going to use this example to demonstrate how the solder is actually melting on the metal, whether it be the wire or connector or motor lead, it doesn't matter. You want the solder or the metal to be hot enough to melt the solder. And that's called flowing onto your part, which people don't really explain that. So if you just glob the solder on the iron and then try to stick it to the metal, well, it may stick there, but it's not going to stay there because the metal never got hot enough for the solder to actually stick to it. So we're not using any flux or anything special, no magic tricks. We're not even going to clean this surface. So in order to get this metal hot enough, we need to transfer the heat from the solder iron to the metal. So what we're going to do is just put a little tiny dab of solder on there, and that's going to allow the heat transfer from this iron into the metal. So we'll put it on the back side of this metal, and we'll heat that metal up, and then when that metal gets hot enough, the solder will actually melt on the metal surface, and it will flow into the metal. So what's happening here is the metal got hot enough for the solder to melt onto the metal. We weren't even touching the iron. So that right there is when the solder is flowing onto that metal. And again, we're not even touching the iron right now, so we know that that joint or that solder on that metal is plenty hot, and it will stick indefinitely, basically, until you remove it with something. So that's flowing the solder onto a part that you're heating up. And that's real important because anytime you do a connector or a motor or a plug or a wire, that piece of metal, whether it be any of those, needs to be hot enough to melt the solder onto that piece of onto that part that you're actually trying to get the solder on. So we'll demonstrate it with a wire. This is a JST plug, which is pretty common in the smaller scale stuff and or accessories like lights or switches or something like that. This wire is pretty small, and it's fairly easy to solder. So again, we'll just clean the iron, and what we're going to do is just place a tiny bit of solder on the iron, and then we're going to put it on the back side of the wire, and we're going to touch the solder onto that wire on this side, and it's going to flow into that wire. And flow refers to the wire actually being saturated with the wet solder. So here we have a 14 gauge wire, which is pretty typical for 10 scale RC cars. So again, we'll put the solder on the iron so that the heat transfer goes into the wire, and then we'll put it on the back side, and then we'll put the solder on the face of that wire, and we want to make sure that the wire gets hot enough so that the solder melts on top of that wire. We're actually not touching the iron there, and the solder melts and saturates inside that wire, and that refers to solder flow. So we've flowed the solder into that wire, and that's something that you need to master before you move forward. So with that, we'll move on to another application, which is pretty common. This is a T-style or Dean's connector, which it was referred to. Now these connectors were absolutely the best thing on the market in the mid 90s, early 90s, and they were just the perfect plug for RC applications. And these are tricky because we still need to get this metal hot enough for the solder to flow, which is that metal needs to be hot enough so that when I touch the solder to that terminal, it's hot enough to melt the solder. The issue with these T-style, these plastic cases or parts here can melt. So I see a lot of YouTubers giving tips on how to prevent this plug from distorting or melting, and what they'll do is they'll plug it into another plug. So now you've got two plugs there together, and this can help. However, you can melt both these pieces if you don't do it right. So if this piece of plastic melts even slightly and you plug it into another plug that you didn't melt together, it may or may not work. So plugging another plug into your plug that you're soldering onto is not a very good idea. All you're doing is potentially going to ruin two parts. I've done this technique and it can work by plugging another plug in there. I'm going to show you how to do it right so you don't have to do this. The trick to these Dean style connectors is to get the heat in and out quickly without melting this plastic, and that's where knowing how to get the solder to flow and the heat to transfer as quick as possible is really the goal here. So put the solder on the iron, we'll touch the back side of the plug, and then we'll put the solder on the top. You don't want to put the iron on top of the plug. You are basically just heating up the solder that is touching the iron. So in order to get a good joint, you need that piece of metal hot enough to melt the solder on its own. What we'll do is we'll put a little tiny bit of solder on the bottom side or top side of the iron, and we're going to stick that right on the bottom, and then we're going to put the solder right on top, and it should only take a few seconds. And you're in and out in, I would say, less than 4 seconds, and that is a perfect amount of solder. So with that method, we didn't distort this plastic. The alligator clip is drawing the heat out of the plug, so we want to be clipped onto the terminal that we're soldering onto. So once we transfer the plug and we go to do our other side, we'll clip the alligator clip to the other side that we're going to be soldering onto. But for this demonstration, all we're trying to do is learn how to get the solder on the terminal, and that's it. You can see how quick it goes. It shouldn't take very long. If it's taking longer than 5 seconds, you're probably going to melt that plug. So here we are with the Dean's connector, and now we've got our pre-tinned wire and our pre-tinned connector, and now we're going to solder them together. So basically what's going to happen is we're going to touch the wire first and then the terminal and solder them together, and it happens quick. So this does take some practice, and you got to be in and out with the heat as fast as possible. So we'll do that right now. And that's how quick it goes. You should have solder all the way around the connector on that terminal, and the wire should be covered and it should be solid. And that right there is a Dean's connection done about as good as it can be done without burning up the plastic. And these do take practice, so I've burnt up several dozen of these plugs, and sometimes it just takes a little patience and some appropriate steps to get it done right. But once you do it a few times, it's really not that hard. So with that, hopefully that helps you a little better understand soldering, and it really can be fairly easy to do. But in my next part 2 video of the soldering, we'll show you how to do XT60s and a new style Dean's connector, and how to use flux and soldering a motor end on. So with that, have fun, stay safe, and we'll see you next time.